Yeah, I mean, it's true. We're kind of skipping ahead because, I mean, actually in this chapter we did 2.1, that was about functions, domain, and range. We did 2.3 and 2.4, which were about the equations of straight lines. And now we're doing 2.7, right? We're skipping over 2.5 and 2.6 because we'll get everything we need out of 2.6 with this lesson. The 2.5 we'll readdress later at a different point in the course. But today we introduce a function which is really a kind of a linear function, but it's a little bit different too. And we do it because it's got a very clean graph, and it makes it easy to see how we use transformations to graph. I mean, we're going to start out by plotting points to graph, and then we'll see how you can actually, understanding how these functions work, you don't always have to plot points. You can actually like move around a basic shape. The absolute value function will be presented as what's called a parent function. A parent function means it's the example for all absolute value functions. And then we learn how we can move that graph around by adding and subtracting and putting minus signs in front and things like that. So these are all coming right out of the SOLs. And most of them are kind of just repeating themselves. But when we get to the last, we go over this again at the end of the class, it'll make more sense. But we'll recognize the graph of the parent function. We'll identify transform functions, things that have been moved around. We'll graph functions, and we will identify transformations, and we'll write equations. All that stuff comes out of this. So the first way that we learn the shape of a new graph is usually to plot points. Just let's plug in some points. Let's draw the graph. Let's see what it looks like. If we didn't have calculators in our hands, that would be the way we try to figure out what something looks like. In this case, I made a table of values already. I think the first few homework problems ask you to do the same thing. Do a table of values and then sketch the graph. So the table of values got a column for x and it's got a column for y. And remember, y equals the f of x. It's the output of the function. I've already wrote in the -2 for x to go from -2 to 2. Where did those numbers come from? Kyrie? Well, we get to choose, right? I put them in there because x is the independent variable. I get to choose what numbers I want to graph. So I put those in. Remember, you choose. Now, I chose those for a reason because I know where we're going with this. Okay, once you've got the x values, then you're going to plug in to the function and generate y values. For example, if I put in -2 for x here, what does the function equal? +2, because what's the effect of absolute value? It makes everything positive. Good. So that's a 2. Okay, when I put in x equals -1, I get 1, right? 0, 0. What do I get in when I put in +1? 1, right? Yeah, and Sam's careful in the way you said it, right? It doesn't flip the sign. It makes everything positive, which means it doesn't change the sign for positive numbers, just for negative. Okay. So those are 5 ordered pairs that we can graph and see whether we can determine the shape of the graph of an absolute value function. So -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Do we see a shape? We see a shape. And the shape of the graph is, looks like it's there, and it's there. That's an absolute value function. And it's very clean, right? It's got a sharp corner on it. It'll be very easy to see as we move things around, how it's being moved around in most cases. We're good, Jaden? everybody? So the absolute value function, right? The shape of the function is a V. You know, if you're asked what's the shape of the graph, it's a V. Okay. The point of the V is called the vertex, right? Right here is called vertex. The vertex, we use these letters to represent the coordinates of the vertex, H, comma, K. Okay. You can see the slope of it, since it's got two sides to the V, right? To the right of 0, the slope of that line is +1, right? It's up. It's going up from left to right. To the left of 0, the slope of the graph is -1. It's always like it's symmetric with respect to the y-axis. I mean, if I draw in a line right there, I mean, this is geometry terms, right? A line of symmetry. The y-axis is a line of symmetry. It looks the same to the left as it does to the right. You know, you would never want to draw the V like on one side it's going off at an angle like that, and the other it's going off at a different angle. No, it's exactly symmetric. Right. Whatever is that line that goes right through the middle, that is called, I'm going to extend it up here, that is called the axis of symmetry. And it's a vertical line, always a vertical line. No matter what we do to the graph, it will always be a vertical line. And do you remember, how do we write the equation for a vertical line? It only got one variable involved. Is it the y or the x? It's x, right? It's x equals a number. The question would be, well, which number would it equal if it's going through the middle of the graph and the vertex, which has a coordinate of hk? I mean, in this graph right here, that line is x equals 0. It's the vertical line going through x equals 0. But more generally, if the vertex has coordinates of h comma k, then the axis of symmetry is x equals h. Whatever is the h value, that's the equation of this line right here. And we don't do a ton with that in this chapter, but in the next chapter, when we get to quadratic functions and parabolas, then we use it pretty much. Same concept. Vertex is the same. Axis of symmetry is the same. So, right. This function, this y equals the absolute value of x, that is the parent function for absolute value functions. All the others are considered to be in the same family, but the parent function is just the basic absolute value of x. Okay, now let's see what happens to our graph when the function is not the parent function. It's slightly different. I've added a number after the absolute value. Okay, and we're going to figure it out by doing another table of values. Yeah. Yeah, you probably already know, but we're just going to like discover these things. This one, you could probably, most of you figure out what's going to happen here. But the next one is probably needs some explanation. Okay, so let's plug in. I already chose the values again because x is the independent variable. When I plug in the absolute value, or x equals -2, then what does the function equal? 4, right? Because you're going to get the 2 comes from the absolute value of -2, and then you add 2. So it actually is going to be 4. Right? And when I plug in -1, it'll be 1 plus 2 equals 3. When you plug in 0, you get 2, and 3, and 4. So let's plot our points. -2, 4. -1, 3. 0, 2, 1, 3, 2, 4. Right? So we can we see the V, right? We can see the V. Let's connect it up with a line. Right, here's one of them. And so what does it look like happen to the graph because we added 2 after the function? It went from here to here, up 2, right? It moved it up 2. Did it change the slope of either side of the V? No, it's still 1 and -1. Did it change the axis of symmetry? No, it's still going right through the middle, x equals 0. Okay. When we add and subtract here, that's called a transformation. It's going to be called a translation. Translation is definitely this. Some of the things we talk about wouldn't be considered a translation, but they're all considered transformations. We're transforming the graph by adding and subtracting numbers after the absolute value. Okay. We ready, Janine? Okay. So when you add or subtract after the function, that's a vertical shift. If it's a plus, it means it's up. If it's a minus, it means down. Yeah.
So when you wrote the excellent equations, the H right at each column K.
What's that now?
Normally we use the little parentheses H column K.
Right.
So would the X convert to the H?
No, not at this point. When we put it all together, you'll see where that comes in. You know, if you're trying to like match up this X with that, no, that's not true overall. There's one point that goes with the K, and that's the H, and we'll get to that. Right. So that's the first shift. That's the easiest shift to understand. Right. Add or subtract after the function. What it means is that when you plug into the function, you're going to get whatever the function value was, and then you're just going to add a number to it. So obviously, it goes up or down just based on what you add. Okay. Okay, next is, let's see what happens when we graph the function, the absolute value of x plus 2 inside, right? Now it's not after the function, it's actually inside the function. When I put in the x equals -4, then -4 plus 2 is -2, and then you take the absolute value, +2, right? I'm still on the line. Right. If I put in x equals -3, -3 plus 2 is -1, absolute value is 1. You put in a 0, you're going to get 0, you're going to get 2, sorry. No, this is -2. Put in -2, you're going to get a 0, absolute value is 0. -1, -1 plus 2 is 1, and 0 plus 2 is 2. So and remember, I chose these points because I knew what was going to happen here, right? It's not a coincidence. If you were graphing the function, if I just chose the -2 to 2 like on the others, I wouldn't see the point of the V, right? If I don't see the vertex, then I really haven't seen the V. So I moved the graph because I know I needed to in order to see the V, right? So if you find yourself plotting points and it didn't show the V, then pick some other points. Okay, -4, 2 would be 1, 2, 3, 4 here. -3, 1. -2, 0. -1, 1. And 0, 2. Right? Do we see the V? Absolutely, we see the V. So let's go ahead and put it in there. There's the V. So what did it do to the graph when we added 2 inside the function? It moved it which direction? Left 2, right? And that can seem like it's a little counterintuitive. You think when you add a number, it should go to the right, because isn't plus to the right? But it's not. Plus means left. Minus means right. Remember, we get this point 0 when what's inside here equals 0. And because that's a plus 2, you need that to be a minus 2 in order to make what's inside equal to 0. That's why it has that opposite sense and drives us to the left. So again, here's where the h comes up, right? If there's a shift, if there's a number being added or subtracted inside the absolute value, that's a horizontal shift. The h does not stand for horizontal, but that is a horizontal shift. Plus, if you see a plus inside the absolute value, that means left. If you see a minus, that means right. Now, if you look at what we just did, right, f of x equals the absolute value of x plus 2. You know, here it says minus. So really what we've got going on here is this, x minus negative 2. Right? So the value of the h is negative 2. Well, just go back and see. We said that the coordinates of the vertex are h comma k. Well, what's the coordinate of that point right there? Negative 2, 0, right? That's why the h is actually negative 2. But when we saw the plus inside, that meant go to the left. It's consistent with that being the h. Right, so up, down, left, right. Okay, now we're going to see what happens when we stick a minus in front of the absolute value. Okay, well, when I put in the negative 2, I take the absolute value and I get 2. And then I put a minus on it and it becomes negative 2. Right? That minus is not inside the absolute value, right? The absolute value has no effect on it. Right? It's just going to flip, it's going to change the sign of every one of our y values. Right? So we put in negative 1, you get positive 1, and then you put the minus on it. You put in 0, you get 0. You put in positive 1, you get 1, and then you put the minus on it. And put in a 2, you get 2, put a minus on it. So there's our 5 points. Let's graph them. Negative 2, negative 2. Negative 1, negative 1. Okay, 0, 0. 1, negative 1. And 2, negative 2. Right? Do we see the V? We see the V, right? So let's connect it up. So what did it do to the graph by putting a minus in front of it? Alicia, how would you describe that? You know, most of the time we're going to say flip. It flipped across the x-axis, right? Flip. So that's wrong. Let's go back to here. Flip. That's not the language they use in the book, right? The book says reflection in the x-axis. And they say that in the x-axis. Now, there is a reflection in the y-axis, right? You could flip something in the y-axis. Is your question, guys? Okay. There is a reflection in the y-axis. The reflection in the y-axis would be like this. Reflection in y-axis. That would be f of x equals absolute value of negative x. If you put the minus inside, that would reflect it like that. What would that do to our v if you flipped it? How would it change the appearance? Right? If you take if you take a V, a perfect V, I think I got one on this side. If you take that there and you flip it across the y-axis, what does it look like? It's the same thing, right? If this line becomes that line and that line becomes that line, and it's the same thing. So that one reflection in the y-axis is not something that's actually easily seen by looking at absolute value. Because it's symmetric with respect to the y-axis, it looks the same thing anyways. So we're not messing with that one. And actually, in the whole course, we don't often do it. Even in pre-cal, when we get to it, there's a little bit of that, but not very much.
So we're not doing that at all.
No. But this is the kind of question that Sam would ask if I didn't say it. What about a reflection in the y-axis, right? Okay, there is such a thing, and that's how you get it. But it's not easily shown on a V that's symmetric with respect to the y-axis. Okay. Okay, so, and I'm going to try to do this. I wanted to be able to take my V, right, and move it around. But actually, this is not a V. This is like one line and two lines, so I can't actually like move the V. So I'm going to try to do something else here to be cosmic and special, right? I'm going to draw myself a V, which is right on top of this one. It's not going to be quite as straight, but it'll be pretty close. Actually working out better than I thought. I hope that works. It may not. Just a second. It probably perceives that as two different lines, and I want it to be one line. Okay, try this again. I need to make it one continuous line. Okay. Now, when it says to graph something without doing a table of values, by using the transformations, that means don't plot a bunch of points. Understand the parent function and the graph and the shifts that you see, right? By subtracting 2 inside, what does it do to the graph? By subtracting 3 after the function, what does it do to the graph? And just move the V, right? Without plotting points. That's understanding the graph. So let's see. Well, it says to describe the transformations. So let's describe the transformations. What is this -2 doing inside the function? Is it going up, down, left, or right? What did we say? Inside the function was horizontal. Minus means left, right? So that is left 2. What is the -3 going to do? It's up or down. Minus means down, right? Down 3. Okay, now let me do my thing. So I'm going to grab my, that's not right. That's good. I'm going to grab my V, and I'm going to go 2 left and 3 down. 2 left and 3 down. Right there. Done. That's how you graph using transformations. Just move the V. Right? Understand the shift, move the V. Does it change the slope of the right side of the V or the left side? No. What's that? Oh, you're right. Good catch. Right? She's right, I'm wrong. Right. It should have been right 2, which means we did the wrong shift. Should go over here. That's right. Thank you. So minus inside means right. Minus outside means down. So you just move the V, right? You don't have to plot points, just move the V. Okay. Okay, so you try to do the same thing on this one. Sketch the graph of this. F of x is the absolute value of x plus 2 plus 1. Right? Don't plot points. Just take that standard V and move it in the right directions. Which way will you move for plus 2 inside, for a plus 1 outside? Which, did you remember the quadrants? 1, 2, 3, 4. Which quadrant is the vertex in? Right? So if you, what are you going to do with the +2 inside? Up, down, left, or right? Left and up. So we're going left and up, which is quadrant 2, right? 1, 2, 3, 4. That's wrong. That's right. So we're going to go left 2, up 1. That should have been your graph. Left 2, up 1. Okay. Try that one. How many transformations do you see in that one? You see the -1 inside, the +3 after, but you also see a minus in front. All three of those are going to change that graph, right? So sketch the graph. Which quadrant is the vertex in? Who's got what quadrant? Shen or Christian? Which quadrant? He's in the first quadrant, right? What are the transformations here? What is the minus doing inside? Right. Okay, there's right. And what is the +3 after doing? Up. Okay, so it's definitely going to be going 1 to the right and 3 up. And then what is the minus telling it to do? It's going to open down, right? It's not going to open up. Okay, let me see if it'll let me do this. Paste. There we go. So first, I'm going to flip it, which I can do like this. Here. Pretty good, huh? And then I got to go up here, go right 1, up 3, and that's not quite straight, right? We know that the slope should be more like that. That looks better. Okay, what would you say is what are the coordinates of the vertex? This point right there. What is it? 1, 3, right? 1, 3. Again, remember in the formula, it's x minus h. H is +1, right? And the k is 3. That's the vertex. So we would say hk equals 1, 3. And what are the coordinates for the what's the equation for the axis of symmetry? Remember, it's x equals a number. What number? Remember, it's this line right here. So how do you name that line? What's the equation? It's x equals a number. Which number? 1, right? It's this number. It's going through the vertex. I mean, the x coordinate of every point on that line is 1, 1, 1, 1, 1. And that's the lesson, basically. So we learn about two things here, right? First, we learn about this concept of parent functions. If we had done the section that comes before, they present some other parent functions. But the whole point of the parent functions is to be able then to go ahead and describe all these transformations. And the absolute value function is really the best one to look at. I mean, if you take, for example, this, right? If, insert page after. Let's say that I used a straight line as a parent function. There's an x-axis and there's a y-axis. And they do this, okay? In the book, they'll call this to be the parent function. It's actually y equals x. Okay. Now, if we want to see how we affect that graph by adding or subtracting numbers, then just imagine this. Not there. Come on. That's the wrong one. It keeps getting the big one, which actually would probably work. You know, imagine this. Oh, it's taking the whole thing. If I draw that graph in a way that moves that line, now I've got to at least be lined up there, up to, like this. I mean, that's definitely up to, right? So you would think, oh, that means that it's y equals x plus 2. But it's actually left 2. At the same time, you could consider that to be a left 2, which you would represent by doing inside the function a plus. And it's the same thing. To me, it's just like needlessly confusing to use that to try to demonstrate, you know, how we adding and subtracting numbers moves the graph around. It's better to use the absolute value, the v, because it's very clean that way. We don't have the same issue. Okay. So go back to this thing here. So at this point, the SOL, actually what it says is, it doesn't say absolute value. It just says parent functions in general. And by the time we're done with the class, we've seen all the parent functions that we need to see. At this point, the one we need to know is absolute value. We know it's a V, right? Vertex at the origin, symmetric with respect to the middle. And then we know how to transform it around by adding and subtracting inside and outside the function, and what happens when we stick a minus in front. It goes from opening up to opening down. And these are just a whole bunch of different ways to show that you know that body of knowledge right there. There is something else to this section, which I'm just not doing with you guys, okay, which is what happens if you multiply by a number. And we'll leave that for next year. Not important to what we're doing this year. So I've tried to pick these very carefully to be just the things that we did today. Right? That's why it's kind of an odd list of numbers.